This video will show you how to calculate the confidence interval for a prevalence. So say, for example, you're involved in a disease eradication program. You've got 217 herds that you've tested, and you've got positive results in 22 of those herds. So we want to know what's the 95% confidence interval for the prevalence. So first of all, we need to sort out our prevalence. And the prevalence is just the proportion of herds tested that were positive. So the number positive over the number tested, we've got a prevalence of 10%. The 95% confidence interval of that we can calculate using an appropriate formula. Now, because this proportion is 10%, that's not a very, very high or a very, very low prevalence, and therefore we can use the standard formula for calculating the confidence interval. So P hat is this value for the prevalence. So calculating the confidence interval, of course, we've got an upper and a lower. The upper is the prevalence plus Z times the square root of the prevalence times 1 minus the prevalence all over the number of herds that were tested. So just double check that all of the brackets are sitting in the right places so that your square root and your multiplication functions are exactly right. Alright, so that's the formula that we're looking at. The prevalence we have, that's here. So everywhere we need the prevalence, we can put that value. N we have, that's the number of herds that we tested. And now we just need a value for Z. Now Z is the appropriate value from the normal distribution, and we can calculate that. It's the absolute value of the inverse normal cumulative distribution, where the probability is 0.025, the mean being 0 and the standard deviation being 1, and we know that 1.96 is about the right number. We can now put in that value and we return our upper confidence interval for the prevalence. If we go through and use F4 to make all of these references absolute cell references, then we can copy and paste that formula into the cell below, change our plus sign for a minus sign, and find our lower confidence interval. So that's all very well and good if the prevalence is moderate, but what if the prevalence was very high or very low? Well, we can copy all of these cells over here and play around with the values to see what the effect would be. So say that we've gone out and tested 300 herds and only one of them came back positive. All of a sudden our prevalence has dropped from 10% down to 0.3%. If you want to see those numbers as a percentage, you can press the percent style sign here on the home tab on the ribbon and then increase the number of decimal places to see what's going on there. Now, of course, these two formulas have kept our absolute cell referencing back over here, but that doesn't really matter because the formula that we've used to calculate over here won't work for such a low prevalence. If we try to use it for such a low prevalence, we can drag these boxes over here to the new cells that we want to look at. You can see that our 95% confidence interval drops down below 0. Now you can't have a prevalence that's below 0 because a prevalence is a proportion of, and you can't have a negative proportion of herds being diseased. So that's one of the indicators that tells us that we need to use the alternative formula for when the prevalence is very low. Now the formula when the prevalence is very low or very high is a little bit more complicated than the previous formula we were using. As well as the prevalence P hat, we now also need this value called Q. Q is 1 minus the prevalence. We might just make these back, and we might just take these ones that are percentages back to general format so that we're not getting confused with them. So we know these formulas are wrong. We'll lose them. I'm going to move these cells down a little bit so we've got some space in our sheet to work. Now first, to calculate this, we're going to need the three quantities that we're calling A, B and C. And if we calculate these three quantities, then we can combine them to find our confidence intervals. The number positive, we're going to designate R. The prevalence, of course, is P, and that keeps us consistent with what's in your study guide. So A is 2 times R plus Z to the power of 2, Z squared. B is Z times the square root of Z plus 4 times R times Q. And C is 2 times the sum of n plus z to the power of 2, z squared. Okay, so we've now got our values of A, B and C, and we can use them to calculate the confidence interval. The upper confidence interval is A plus B all over C, making these absolute cell references. We can then copy and paste it below and change our plus sign to a minus sign to get the lower confidence interval. And you can see now we've got a positive but very small value for this lower confidence interval.